Hi, we're going to practice graphing rational functions. Okay, so we want to graph f of x equals 2x minus 7 divided by x minus 5 or over x minus 5. We want to rewrite it in the form a equals x minus h plus k, because that's the form we've been learning how to graph. So we need to rewrite it by dividing 2x minus 7 or dividing it by x minus 5. We can either use area model to divide or synthetic substitution or synthetic division. So I'm going to use synthetic. For dividing by x minus 5, we put a positive 5 on the outside. And then I'm going to put the coefficients for 2x minus 7 along the top, 2 and negative 7. So we bring down the first number and then multiply to 5. We get 10, and then add. So the number you get at the end, the 3, is the remainder, and we put that over what we were dividing by, which was x minus 5. And then the 2 is just the constant by itself, so I'm going to put plus 2. I'm just going to switch this around so that we put the fraction part first. 3 over x minus 5 plus 2. Okay, so the way we start graphing is starting with the parent function. So the parent function is just 1 over x, and you can kind of memorize those points or just plug in numbers into 1 over x. So for example, if you plug in 1 divided by 1, or 1 over 1 is just 1. If you plug in 2, 1 divided by 2, or 1 over 2 is a half. We also wanted to plug in a half so we can see what's happening closer to the y-axis. So if you plug in a half, you get 1 over 1 half. We're plugging in 1 half for x. 1 divided by 1 half is 2. And then I'm going to plug in the negatives of those so we get some values on the left side of the y-axis. So I plug in negative 2, I get negative 1 half. Negative 1, we get negative 1. And then negative 1 half, we get negative 2. So these are the 6 points that we want to start off with the parent function 1 over x. Okay, and then we're going to transform it. So there's a 3 in the numerator. That's the a value. A is 3. The a value vertically stretches these points by 3. So we're going to multiply the y values for the points that we just graphed. We're going to multiply them by 3. Multiply the y values by 3. So for example, if I'm looking at this y value of 2, the point is 1 half 2, I'm going to multiply the 2 by 3, and now it is 6. So it's vertically stretched by 3. And I'm going to graph it here. Now instead of 1 half 2, it's 1 half 6. I'm going to go ahead and do that with the rest of the points. So if I look at the point 1, 1, the y value is 1, and now the y value is going to be 3, because 1 times 3 is 3. The next point after that is 2, 1 half, and if I multiply 1 half by 3, 1 half times 3, that's 1 and a half. So now it's there at 1 and a half. And I'm going to do the same thing to the points on the left side of the graph. And then once I multiply by whatever a is, I'm multiplying the y values by a, then I'm going to shift according to the negative 5 and the plus 2. That's going to tell me where to shift. So the minus 5, because that number is with the x, that's going to shift to the right 5. So the number that's added or subtracted to the x tells me where to shift horizontally, and you do the opposite. Because it's minus 5, we're going to go to the right 5. And then the 2, the plus 2, so the number that's the constant that's by itself, it's separate from the rest of the fraction, is the vertical shift, and that one we don't switch the sign. I'm just going to shift up 2. So I'm going to take all of these points and just count over all the green points. The blue points were the original parent function. Now I'm looking at the green points because those ones were multiplied by 3. I'm going to shift each of the green points right 5 and up 2. So for example, if I go to this point here, I would just count 1, 2, 3, 4, 5, 1, 2, and now it's there. Okay, so I've shifted all my points to the right 5 and up 2. That's where those red points are. And then now I want to try to connect them and then also draw the asymptotes. So I'm going to go back to the original parent, and if I would have connected these points, the parent function looks like this. It has these branches that go along the x and y axis, and they never touch the x or y axis. So the x or y axis, the x and y axes are asymptotes. So I'm going to draw kind of dashed lines there to show that the parent function was never crossing those lines, those asymptotes. So now I want to shift the asymptotes because everything shifted to the right 5 and up 2, just like the coordinates. So the asymptotes were originally crossing at the origin, and now they're shifting right 5 and up 2 and crossing here at the point 5, 2. So now they are here and here. And now I kind of have a lot going on, so I'm going to erase everything that I don't need, the original points and the original asymptotes. What I want to end up with is just my red coordinates and the horizontal and vertical asymptotes that I just drew. Okay, so I got rid of all those original points that I ended up transforming, and I don't need them anymore. I'm going to connect my new coordinates. Again, they go along the asymptotes, they don't cross the asymptotes. And I just realized I left a little piece of the original asymptote over here. I'm going to erase, and down here. And then I'm going to connect these other points. So here's my graph. I have these two branches. And then it says we want to state the domain, range, intercepts, asymptotes, and end behavior. Okay, so let's start with domain. Domain is always going to be from negative infinity to wherever the vertical asymptote is. So if we look at the graph, there's nothing graphed at this point where this vertical asymptote is at x equals 5. There's no x values here. But there's x values to the left and there's x values to the right. There's just no x values at x equals 5. So for the domain, it is from negative infinity to 5, not including 5, and then 5 to infinity. The range is similar, but now we're looking at the y values. There are no y values here at 2. There are y values graphed below that, and there are y values graphed above that, but there are no y values, there are no outputs at y equals 2. So my range is going to be from negative infinity to 2 to positive infinity. The intercepts, I'm going to come back to. My asymptotes are, I'm going to point to them again. So this vertical asymptote is x equals 5. That's where it's crossing the x-axis at x equals 5. And then this horizontal asymptote is at y equals 2. So the horizontal one is a y equals, that's where it's crossing the y-axis at y equals 2. And then I'm going to come back to the intercepts. I'm going to talk about the end behavior now. So end behavior, the ends of the graph, so I'll start with the right side. As x approaches infinity, that means as you're going out to the right side of the graph, the function is getting lower and lower, but it's not going to negative infinity. It's getting closer to this horizontal asymptote at 2. So the function is slowly approaching 2. F of x approaches 2. And then same thing on the left side. So this means as you go to the left, the function is approaching 2. So these ends will always be whatever the horizontal asymptote is. So you have y equals 2 here, then these ends for the end behavior are both 2. Okay, let's go back to the intercepts. So for x-intercept, it's crossing the x-axis around here. Looks like about 3.5, but we want to find it exactly. So the way you find an x-intercept is you set the equation equal to 0 and you solve for x. And then for the y-intercept, it's about 1 point something. It's between 1 and 2. We don't want to just estimate, we want to find it exactly. So to get a y-intercept, we plug in 0 for x, and then we just simplify, because when you're on the y-axis, x is just 0. So we're going to plug in 0 for x and simplify to get the y-intercept. Okay, so let's do the x-intercept first. I'm going to take the equation, and I'm going to set it equal to 0. So this is for the x-intercept. You take the equation, set it equal to 0. I'm going to subtract 2 from both sides. We're trying to solve for x. And then I'm going to multiply both sides by x minus 5, because I don't want x minus 5 in the denominator. I want to get it out of the denominator so that I just have 3. And then on the right side, I'm going to distribute the negative 2. So negative 2x plus 5, or plus 10. Now I need to solve for the x. I want to get the x by itself. So I'm going to subtract 10. Negative 7 equals negative 2x. And then divide by negative 2. We can leave it as 7 over 2, or that's 3.5, or 3.5. So this is the x-intercept. And the y-intercept, you take the function and plug in 0 for the x value. And simplify. So negative 3/5 plus 2. I'm going to rewrite this as negative 3/5 plus 2 is the same thing as 10/5, so I'm getting a common denominator. And then negative 3 plus 10, 7 over 5. We can leave it like that because it can't be simplified, or this is the same thing as 1 and 2/5, or 1.4. So you could write it any of those ways. That's the y-intercept.